Hello, everyone, and thank you for being here. My name is Per Christopher Undheim, and I'm the product manager for DBWatch Control Center here at DBWatch. I have a background as a DBA, and today I will focus on a task that is near to my heart, automating day-to-day maintenance to have more time relaxing as a DBA. So if you have any questions during this presentation, there is a Zoom chat option where you can send in questions that we can go through later in the question section at the end of the webinar. In today's webinar, there are some key areas we want to focus on. First, we will go through the content of the maintenance package, how it's deployed, how maintenance jobs are configured, and how farm views are used to maintain control of database deployment and progress. During this webinar, we will use a simple database environment consisting of some SQL Server instances. But as we have many attendees here today that don't have a lot of experience with DBWatch Control Center, I will quickly show the product. So here I am in the main screen of DBWatch Control Center, and on my very left here, I have a menu bar. These are the different modules of the product. On the middle here, I have a tree-like structure of the databases in my environment. So I'm logged in with my user, and this user in the demo environment only sees SQL Server database instances. This environment is possible to have fully cross-platform with databases of many different vendors and types. In my structure on the side here, I am connected to one data center. DBWatch Control Center allows you to separate your data centers, different security zones, different data centers, locations, etc. But in my environment, I'm only connected to one. And I only have one group, production, where I have a always-on cluster with 3 nodes and some single instance databases. And these can be structured and contain different type of information. These 3 allow you to structure on things like customer name, application type, data center location, anything you want. In the main screen here, I'll see all the alerts I have on my database systems, and they're sorted by severity and status time. So I have the last worst alert on the top here. So I have alarms, and then if I scroll down, I'll have the warnings later on. So there's lots of things wrong here, but that's how life is in my demo environment. On the bottom, I have a sort of traffic lights where I have 0 databases currently in lost connection. This will turn into a blue ball, the blue ball of shame when there is databases we've lost connection to. And we have 3 databases with some sort of alarm or 1 or more alarms. And we have 4 with warnings, 1 or more warnings. And we have 1 that are all okay. And we have no databases added for other purposes than monitoring, like management and reporting purposes, which you can. You also have a tab on the top. So there's other things like lists of instances where you can change the contents here, and you can add your own dashboards for this overview as well. If I go to a specific instance, we get insight into what has been added on monitoring on the system. We see it's the name we've given it is Underon. It's in the production group. It's a SQL Server 2017 Standard Edition, the host, when it started, and the number of databases on it. And we see we have some jobs with status. They are the ones that create alarms and warnings. And we have some jobs without status, and they are collecting data for capacity planning, performance, maintenance jobs maybe, or other types of purposes that don't give alarms. Each of these will have some small status. They will have, if they're in warning or okay, name of the job, when it's last run, the schedule, next scheduled run, and then details from the last time it's run. And each of these will will be able to run a detailed report on each of these metrics to dive into things specific on this database instance. If we look at one of these jobs details, this will gather data from the database on current state and historic states in the database regarding this specific performance metric, which is CPU utilization, and we can see how this database has run over time with a lot of different statistics in different types, part of the day, etc. If you detect problems in the monitoring of your databases, it's important to also be able to jump into other parts of the application for management of the database. So you can go to management, and here you have overview of the system. You can do a lot of adjustments. You can look at the performance on the system, drill down into performance peaks, etc., and dive into statistics on the different queries. And all the things that you do in your day-to-day operations with databases. Dive in, and you can also run SQL statements on the system if you have custom things that you want to run. This area where you can drill down into anything in the database. Here you can also add menus and buttons to expand the product as well. The next module in this list is the farm views. Farm views are where we want to look at one metric across your database environment, and it's the opposite kind of view from monitoring, where we look at one database instance and see a lot of the metrics on that database instance. Here we look at one metric and how that is across all database instances. So there's insights to things like how the disk is filling up on your environment, and a lot of different things. So it depends on what you want to dive into. We have a SQL worksheet, allows you to run queries on one or more database instances. Can be also cross-platform if the query runs on different platforms. And this can be used to run scripts or and get the data or look for data across your systems. Also extracting data, of course. We have auto discovery, allows you to scan different network segments to see databases not added to the product. This is useful if you have parts of the organization that deploy databases without asking the DBA, and then ask you only when they need recovery of the databases. And you have not seen it yet, and there is no backup. Next is FDL console. FDL is for farm data language, which is a data warehouse type language built into the product, allows you to query for any data point on any server or any database you have underneath, and allow to structure those data into tables and display it in different ways. So this is an example where we use the same query that we run in the monitoring, but here in FDL console to maybe adapt it or adjust it, and you see it gets different data from the instances and merge it together and create this data set. This is useful if you want to get in-depth information on how data is across your environment, but also to export specific data sets for other purposes, like integrating with other tools, or exporting data to other applications. We also have the reporting. There is a specific webinar on the reporting, how to customize reporting, etc. You can select instances you want to run reporting on, see the reports that you have. And I've cheated, of course, so I have a report already because it takes a few seconds to create. And this gives insight into like the health check of the database and a lot of different metrics. You can dive into what's happened on the system. So that's a bit about DBWatch. It's a lot to go into. If you are interested in more detailed demonstration of DBWatch, you can go on the web page insight, request a demo, and then have a custom demo with me to go into your specific needs and how this can benefit your business. So let's get back to the main purpose of today, which is database maintenance routines. So databases are the backbone of any business, and like any critical system, they require regular maintenance to stay healthy, secure, and high-performing. And without proper maintenance, SQL Server databases can suffer issues such as slow queries, fragmented indexes, bloated data files, and even corruption. It's like having a high-performance car. If you don't regularly change the oil, check the tires, or service the engine, performance will decline and eventually the car breaks down. The same applies to your databases. Over time, indexes become fragmented, affecting query performance. Unused space in the database leads to inefficient storage usage. Without routine integrity checks, corruption can go unnoticed until it causes data loss. SQL Server provides built-in tools for this, like dbcc checkdb for consistency checks, and there is index maintenance task, but manual execution is time-consuming and error-prone. And that's why automated maintenance routines are crucial. They ensure indexes stay optimized, databases remain corruption-free, and backups are always verified. So your business can run smoothly without unexpected downtime. In today's world, where data availability and performance are critical, having a well-planned maintenance strategy is not just best practice, it's a necessity. When it comes to maintaining your SQL Server databases, there are several ways to get this job done. And the first option is writing your own scripts. And many DBAs, me included, have created a lot of custom T-SQL or PowerShell scripts to handle tasks like index maintenance, integrity checks, and backups. And while this offers flexibility, it requires constant upkeep and testing and debugging. And as your environment grows, managing and deploying these scripts across multiple servers becomes a challenge. And another approach is downloading a set of scripts from the internet. And there is a great community maintained scripts like the Ola Hallengren maintenance solution that offers solid automation and scripts. However, these scripts are not tailored to your specific environment, and they still require manual configuration, adjustments, and ongoing maintenance. Plus, troubleshooting issues means relying on forums and personal experience rather than the dedicated support we provide here. So the third alternative is using a professional maintenance automation tool like we have in DBWatch Control Center. And with a dedicated tool, you get pre-built, tested, and optimized maintenance jobs that can be deployed consistently across all your database instances. You gain monitoring, reporting, and centralized control, making it easy to adjust maintenance parameters across your entire infrastructure. More importantly, you have vendor support, ensuring that your maintenance routines remain effective even as SQL Server versions evolve. So while scripting works for some, a fully supported automated solution not only saves time, but also ensures reliability and scalability, letting you focus on performance optimization rather than maintenance firefighting. Maintenance routines need to be deployed out to all the database instances you manage. And you need to make sure that they are implemented in the right version and upgraded if needed. There can also be different maintenance routines for different database versions or groups of instances, such as test and production. Proper deployment is time-consuming if you have to either do it manually or maintain your own system for pushing updates, reinstalling code, and running jobs. With DBWatch, you can deploy and upgrade new routines in seconds with a few clicks. As your environment grows, the more complex it becomes to deploy, run, and control what maintenance routines are running and still are running and haven't crashed, and where there are any other issues. Before you can use the maintenance jobs, you need to enable the license. And if you are in the testing phase of DBWatch, it's already included in the demo type license, but for normal customers, license is part of the maintenance package. So I'll show you how you can see how this is available in the product and how you can apply it. So let's close this. And if you go to server configuration, manage licenses, you will see what kind of licenses you have available in your setup. And if you are in the testing phase, you will have the demo license available. And if you have a production license, it will look like this. You have production, which is monitoring jobs, mostly covering everything except what is part of the SQL performance package, which is historical SQL performance drill down, the security package, which is security and compliance checks and analysis of your compliance stance, and the maintenance package, which is what we're focusing on today, automated maintenance jobs for SQL Server. So you need to either have the demo or the maintenance package enabled to be able to see the maintenance jobs. If you, let me see, yeah. If you're planning to deploy maintenance on more than a few systems, we have template-based deployment, which makes your job a lot easier. So templates are sets of jobs and their configuration that you can enable on individual or groups of database instances. In this way, DBO's Control Center makes sure that the correct maintenance jobs are installed and configured correctly on all systems. So let me show you in the application, close this. So in the job templates here, when you install a DBWatch server, you get a set of bundled templates. So these are example templates or default templates that are used for deployment, but you can adjust these templates. So if you want your own maintenance template, you can right-click, create a copy, and then you'll have local templates that you can adjust. In a template will be a set of monitoring jobs. You can click here to add jobs for different instances. There is a lot of jobs to choose from. You will see them in the maintenance group. So in maintenance group. And when you add them to the system, you can adjust the jobs you want, and you can click on job details. And here you'll see all the parameters that can be adjusted in the maintenance job. And while we try to configure these as best practices or what works with most users, you can also override the parameters that we set, either the scheduling of the job or the parameters that adjust how this specific maintenance job is going to interact with your databases. If you do changes to any of these jobs, it will show up in the overall dashboard here. So as where we override schedule and the parameters to the task. And then once you are happy with your templates, you can go to either an instance like this, configure jobs, and you will see what templates this is part of. So currently it's have the default template, which installs a lot of the monitoring jobs, the maintenance template, and it also has SQL performance template installed here. And you can see in this overview what jobs will be installed in the templates that you have. On this system, we have the template mode keep others, which allows you to do manual deployment also. So if you want to do manual deployment, which means adding individual monitoring or maintenance jobs to your system, you can do that in the custom area here to add individual jobs. So this can be used in scenarios where you have a maintenance template that is going to be used for 90 98% of your database systems, but on 1 or 2 more systems, you want something specific set up. And then you can go and add those specific maintenance routines in the custom area. But then you have to have the keep others mode. If you have disable or uninstall, it will be very strict and uninstall anything you do in the custom. So once you do changes to this, you can sync, and it will automatically make sure that the maintenance templates and everything is deployed on the system. Let's see. So once you enable the license, these maintenance jobs are visible for you to install. So if you don't enable the license, not a lot will show up here. And I will look into some of the maintenance jobs and what they do. So you can broadly separate the maintenance jobs into 4 categories. Configuration jobs, that looks at configuration, adjusts configuration. Backup jobs to automate backup. And then performance optimization to focus on adjusting performance on your databases, and integrity jobs to check for corruption, etc. So typically configuration jobs are the ones that adjust like auto growth, auto shrink settings. We will so they are adjusted depending on the current size of the data file. So that kind of attention needs you need regular attention to adjust these things. So because the setting you want to set might depend on the current size and how they grow the data files. So while these are the auto grow and auto shrink settings, they adjust configuration settings, but the impact of them are felt more as a performance improvement, as the wrong adjustment here will lead to fragmentation and degraded the read and write performance over time. So it's hard to detect early on if these are not correct, but it will grow into a problem over time. So with the database and server principal mapping, this will detect an alert on things like orphaned users and help correct the mapping as well. So this problem occurs typically when data is moved or restored, but will lead to users or applications not being able to log in. And the page verify option check adjusts so all databases are set to checksum to prevent the database corruption. When it comes to backup jobs, they are included here, and these were originally created for customers that needed to run backup of SQL Server desktop editions, as you have no SQL Server agent available. But they're also adapted to run standard SQL Server instances and do all the backup. So even if you have a third-party backup solution, it's good to have an addition you can use on dev test systems or on your desktop editions. But there is nothing stopping you from using this on all your databases as well, if you don't have a third-party solution. External fragmentation is one of these checks. It checks for external fragmentation of your database, basically how scattered your index data is on disk, which can slow things down over time. And it starts with a quick scan of all the indexes to find the most fragmented ones. And then it takes a closer look into those, gathering more detailed information, including how often they are used. And all this data is saved so you can track fragmentation trends and decide when to run index maintenance, helping you to keep performance smooth and efficient. And the internal fragmentation check, internal fragmentation happens when there is too much empty space inside an index or table page. And some free space is normal and even helpful, but too much of it will slow down queries and make indexes larger than they need to be. If pages are too empty, SQL Server has to work harder to read through them. And if there is no space left, it has to split pages during inserts, which uses extra system resources. So the job only looks at online writable databases that aren't part of any replication or read-only setup. So it focuses on what is actively in use. And we have quite a few jobs looking at some type of index management. And these jobs help your indexes stay in good shape so that the queries stay fast and efficient. Rebuild indexes, for instance. This job completely rebuilds fragmented indexes. It's like starting fresh. Pages are reorganized, fragmentation is removed, and fill factor is applied. And it's best to use for heavy fragmented indexes. And the configuration of that job also reflects that. For all these jobs, there are some in-table variants, which it's used to run perhaps with different schedule and parameters on indexes for specific named tables you have to configure. So it's usually implemented for indexes that are maybe outside the limit of what rebuilt indexes would automatically rebuild, too large, etc. And you want to do the rebuild of those at specific time frames or specific times for your system. Reorganize indexes is a lighter online-friendly operation. It reorders the leaf level pages on the index without rebuilding it entirely. It's great for mild to moderate fragmentation where you want minimal impact on performance. Update index statistics. This job updates the stats SQL Server uses for generating query plans. Fresh statistics helps SQL Server choose the most efficient path for queries. It's important to keep up to date, especially after many data changes. And then we have things like the suspect pages job. This job checks for suspect pages in the SQL Server database. These are data pages that SQL Server marks as possibly damaged or corrupt. It scans the system table MSDB DBO suspect pages, which SQL Server updates when it detects an issue during normal read operations, like from DBCC check DB, query activity, or IO errors. And this job helps you detect early signs of data corruption and monitor when and where these issues happen, and keep a history so you can track these problems over time. It's a small but important job for maintaining database health and integrity, especially on systems with a lot of disk activity or older storage. The cleanup MSDB history tables job, and that this cleans up old records from the MSDB system tables. This is the ones that store history for jobs and backups and resource and maintenance plans. And over time, tables here can grow large and slow down performance in SQL Server Agent and the MSDB database itself. This can make it harder to run or even view job histories. And this job helps you to remove outdated job and backup history, keeps MSDB lean and efficient, improving the performance of tools and views that depends on MSDB. And you can configure how far back you want to keep history, so it's easy to balance between performance and audit needs. The cycle error log job rotates the SQL Server error log, which is where SQL Server writes startup messages, errors, and important events. And by default, SQL Server just keeps appending to the same log file, which can get huge over time and make it slow and difficult to open. And the cycle error log job helps by starting a new fresh log file, keeps the log files manageable, making it easy to find recent issues without digging through massive files. It's a quick, low-impact task that improves log readability and helps with daily troubleshooting. And one of the more serious risks to the database is corruption. It can cause missed records, bad data, or even complete failure. And the scary part, you won't even notice it right away. And that's why the DBC check DB is one of the more important maintenance tasks to have running on SQL Server. It scans your database for corruption, checking pages, indexes, and system tables to make sure everything is healthy. And without it, you are flying blind. Problems might go undetected until user starts complaining. And by then, recovery could be difficult or even impossible. And I have seen many times that when the customer starts noticing this, it can be 6 months before where the corruption happened, and it might be outside the backup window, and there's a lot of hassle involved in trying to reconstruct or get the data back. And in DBO's Control Center, this check is fully automated. You can schedule it across all your SQL Server instances and get alerts if something is wrong. No manual work needed. And this is like health insurance for your data, catching problems early and helping you avoid disasters before they happen. And this, we provide also dashboards for this, so you could have a full overview of how the DBCC CheckDB works and if there is any issues on the system. All the maintenance jobs we have share some characteristics. So like defined schedules, either daily or weekly, but usually outside the business hours. So most of these maintenance jobs are by default configured so that they will not be possible to trigger in working hours of the system. And they're designed to run over extended periods of time so that they can also start and when the maintenance window is close to ending, it will stop working, and then it will pick up again the next time there is a maintenance window to be able to run these jobs. And all the maintenance jobs also makes changes to the database. Once the maintenance jobs are deployed, they end up in the maintenance group on each instance. And they will be scheduled to run with the default schedule, and they will keep running outside of business hours. So, and let me see in the product how that looks. So on the system, we can go to the maintenance tab, and this will give an overview of the maintenance jobs. So if you have things like other packages like security and compliance, it will show up as a package like this as well. And here we see we have some of the maintenance jobs are put here. They create alarms when there is something wrong. And we have also some of the maintenance jobs that don't create alarms. They just run and gather statistics or reorganize things that needs to be reorganized. And each of these will have a schedule that are typically if they do have a lot of impact or are taking out of performance, like reorganizing indexes, etc., they will run outside of business hours and usually at scheduled at different parts of the night. If you have a large environment with hundreds and hundreds of database instances, you could probably benefit from having different maintenance plans for sets of instances so that if they have shared the same kind of hardware underneath, you'll have maintenance plans at different intervals deployed on different sets of instances so that they don't do the same reorganizing index at the same time on all database instances, of course. Each of these maintenance jobs will have, let's see, will have a configuration. So maybe easy to show in here. So when it comes to reorganizing indexes, configure, it will be things that can be adjusted on each of these. And there's typically how long can the rebuild job take? The maximum minimum fragmentation, the minimum maximum size of the index to pick up. And so this allows you not to pick up indexes that are very, very large to automatically reorganize because that can, in some systems, that this can be a problem if they're super huge. And then you might use the reorganized indexing table where you have a specific schedule to look through those. And then you will have a list here of the different tables that you want this job to look at. Each of these jobs will have reporting built in. So they will have reporting to allow you to dive into history on how that specific maintenance job has run on your systems and what they've found, what the impact is, and any improvement they have. There's also dashboards that allows you to verify how the database is doing and how the maintenance routines, where they are deployed, where they've run into any problems of the databases, and where you need to put your attention. And if I show you here in the tool, so they are under farm and maintenance overview. So this will list, so you can see where the maintenance jobs are installed, how many are installed on each system, how many here. And let's see, I can expand. In this overview, we see that we have DBCC check DB on all systems, analyze index are not on all, but are on most, and if there is a yellow icon here, there is something that we should look into on these systems. And this gives you a bird's eye view on how is my maintenance running on all the systems. Is everything fine? Do I have any severities? So here we have different issues that need to dive into, but you'll have a full overview of how this is deployed and whatever they have run into of issues that you need to correct. And similarly, if you go to a specific check, so this is DBC check DB, you will have more insight into how this is performing, if there is things to look into. So this might, it doesn't seem to have run yet, so that's probably the problem here. And you can then, of course, highlight and go into details and reports here. Similar with other statistics, you can go in and see if it's been run through all the databases, if there's any improvement, etc. So these have been running for quite a while, so it will only be minor improvements on it as it goes through the databases it's been configured on. And you'll get an overview of how they are performing. So to wrap up here, automation of maintenance routines is an important step to gain full control of your database environment. And with easy and flexible deployment of tested and supported maintenance routines, you get alerts when things go wrong, and you can stay in control with overview dashboards and reports. This will create a more stable and predictable database environment that will free up time both in the development and deployment, but most importantly, in the time you spend fixing problems in your database environment. If you want to try out how the automated maintenance routines in DWatch Control Center can help you, there is a QR code on the screen where you can scan to register in the portal and receive a 3-month trial license. There is also an upcoming webinar on SQL performance, and you can scan the QR code for that to sign up for the next webinar. And then we will see if there's any questions from the panel. And I see. Yeah, can we customize the maintenance template to fit our internal needs? So yeah, it's a bit. I went into that a bit earlier, but let's see. It's in the job templates. So typically, what you do is that you go and create your own maintenance template. Right-clicking here, create a copy, and then in that template, you can add different jobs. here you can, it allows you to filter, so it's a bit easier to find the different jobs that you want to add. So let's see. So maybe you want to add the selected. It will go into the, so it was SQL Server performance counters adjustment, and you can see if there is any parameters to adjust. You can adjust the parameters here, and then when you save here, you will have your maintenance template set up, and then you can deploy that on a set of systems. Yeah, so what kind of alerts or notification? Yeah, so when if you have maintenance jobs that create alarms and warnings, so the question is, what kind of alerts do you get, and how do you get it? So all the jobs that have that create alarms and warning here will create a alarm message. And if you configure, go here and configure email extension, enable and configure, you can adjust the enable something like this, and then you can adjust the filtering of jobs, etc., and who gets the message and in what format. So this will allow you to filter on the different things. That it can be you can give also filters on individual maintenance jobs, or maintenance jobs that are in a different group, or etc. And you can then filter that and send it to the people that your own email, etc., when there is an alarm. It's also possible to integrate either with the command line interface or with the web server dashboard for DBWatch that allows data exports of alarms, etc. So I don't see any other questions here today. So I will move over here, and thank you all for attending this webinar. I hope to see you again at the next webinar on SQL performance. And if you have any questions, feel free to reach out either to sales@dbwatch.com or to support@dbwatch.com, or to go to the web page and request a demo with me. So with that said, thank you all for attending, and have a nice day. DBWatch Control Center, redefining database operations. Please visit us at Facebook, Twitter, LinkedIn, or YouTube.